So, I am Susan Ingalls, and I direct Sustainable Furnishings Council, and I'm delighted to welcome you all to this series of conversations that we are calling SFC Next. These are conversations that help companies think smarter about sustainability and that help consumers find products and information that they need much more easily. Products that they need to furnish their homes in a way that is healthy and low impact in their environment. So healthy at home and healthy in the world that their home is in. And so, thank you all for being with us. I do want to say a few words about who we are. Sustainable Furnishings Council is a membership organization, and our members are companies that are involved in the home furnishings industry in various ways. So our members include companies that provide materials used in home furnishings, such as Ecovative, that's our featured guest for this hour's conversation. Our members also include manufacturers of furniture products and stores that sell furniture and other furnishings products, and interior designers that specify products. All these companies make their own commitment to sustainability, to transparency, and to continuous improvement. And we, as an organization, make it our business to support them in realizing their commitment. So we provide them with guidance, we provide resources, we provide education, like this series of conversations, and for companies that qualify, we provide marketing support. Companies that qualify use our member seal in all their marketing and advertising, and those companies are also found on our website in a finder device that we have there. We are delighted to be offering this series of conversations that we've got, that we're in the midst of now, this series of conversations called SFC Next. We are airing these conversations live from the headquarters of World Wildlife Fund. World Wildlife is one of our member organizations, and we really, really appreciate their support in providing us the opportunity to be in their space today and in all their participation in our organization. Other sponsors of today's conversations include Belfort Furniture, Nourison, Levico, McCreary Modern, Crescent Fine Furnishings, New York Now Artisan Resource, Room and Board, Vaughn Bassett, Surya, Home Trends and Design, and Naturepedic. Thank you to all these companies for making this series of conversations possible. The conversation that we are starting now is about innovations in materials. We've been talking in earlier conversations about the problems of so many materials being loaded with toxins, and about the challenges of getting good wood resources sometimes. And we've got lots of good ways of finding good wood resources, but it's important for us to understand what alternatives there are, especially to engineered wood products. So that's going to be a topic in this hour. We're going to feature information that Gavin is going to provide us. And in just a moment, Gavin, I'm going to turn it over to you for you to tell us all about what you all do at Ecovative. But I want to tell you that what Ecovative is, and Ecovative is a member of Sustainable Furnishings Council and is also a recent winner of an innovation award that the Cradle to Cradle Products Innovation Institute gave a few months ago. So Ecovative looks to nature to grow rather than to manufacture the next generation of high performance materials. and Gavin is the co-founder and chief scientist at Ecovative. So Gavin, I am going to let you tell us more about yourself and how you happen to be doing this business and what you all are doing and how, okay? Thank you for being with us. Oh, wait a minute, Gavin, I've got to interrupt you. I forgot something very important. The very important thing is that we invite our entire audience to ask you and me questions. Our audience is invited to tweet questions in using hashtag SFCNext and to send questions in by Google Chat, whatever way suits you. So send in those questions, and Gavin knows all the answers, don't you?
I will answer them to the best of my ability. I'm sure I do. Thank you, Susan. So I really appreciate the introduction, and my name is Gavin McIntyre. I'm one of the co-founders and the chief scientist at Ecovative Design. And as Susan mentioned, Ecovative is truly a revolutionary new biomaterials company. And we're positioning ourselves to challenge the paradigm on how materials today are both manufactured, used, and then later discarded. Rather than using high embodied energy processes and finite resources, namely fossil fuels, which are often the precursors to things such as urea formaldehyde or the resins used in engineered woods, or even the precursor materials to things such as protective packaging that are used to protect furniture and transportation, we've looked to nature to grow rather than traditionally manufacture the next generation of high-performance materials. This technology began back in 2007 when myself and the other founder, Evan Bayer, were actually just seniors in college at Rensselaer Polytechnic Institute. Evan really came up with the initial insight, seeing mycelium, what you can think of as mushroom roots, looks like this, grow on and bind to things such as wood chips or farm waste. And at Ecovative, we use a lot of corn stalks, for example. That's what I hold in my hand right here, all of which are regionally sourced within just 50 miles of our manufacturing facilities. What he noticed was mycelium was able to grow on and bind together wood chips. And that aha moment took him from how do we take this natural process, which serves as an adhesive, and scale it up into an industrial process. So today, what we have at Ecovative are two large-scale manufacturing facilities, which are focused on products that range from lightweight foam replacements, things that replace things such as expanded polystyrene, or the white plastic foam you see in protective packaging. One of our first customers was Steelcase Furniture, and we actually grow protective packaging cushions for furniture companies such as Steelcase, Crate and Barrel, and Community Playthings today. And then we've been able to expand that product range, starting to look into and beyond what traditional plastic foams are being used, and into the burdensome and toxic materials used in engineered woods, which is what I'd like to focus on predominantly today. Since engineered woods are predominantly reliant upon things such as urea or phenol formaldehyde. Formaldehyde, of course, is known as a human carcinogen, as it was deemed in the 2011 Federal Toxicology Report. And today, leveraging the same adhesive that we can use from nature, fungal mycelium, we've been able to grow and bind together everything from farm waste to wood particles to create drop-in replacements for engineered wood, such as medium-density fiberboard, particle board, as well as plywood. This technology began about 6 months ago, so we've been developing engineered wood replacement for just a short duration of time, but it takes advantage of a lot of off-the-shelf and traditional processes. So today, one of the things how we collaborate with our customers, one of our first customers is Gunlock Furniture, who provides chairs and predominantly office furniture, came to us because they had a design problem. And that design problem was they were working with a molded plywood product. It's this product right here, actually. And what they were finding is that molded plywood didn't have a great yield rate. It was still relying upon synthetic adhesives, and of course, it was very expensive. Using our technology, we were able to grow these materials to the final shape, press them in the magnitude of just a couple of minutes, and result in a high-performance and beautiful product. So this is our chair back. It's upholstered, just like a traditional chair back. It's used as staples, as well as Christmas tree clips to mount it right onto the side of a chair. So today they have a urea-free, VOC-free, flame-retardant, 100% bio-based, natural alternative for the engineered wood that they were using formerly. And today you can find this product in the Saver chair that's sold by Gunlock Furniture.
That is very, very cool. That is a wonderful thing to hear about. Just as it's especially just now, as we've been hearing about all the toxins in our furnishings products, and especially the toxins in foam. So I want to ask you a little bit more about foam replacement, Gavin. So the things you've showed us are firmer than the cushioning in the chair I'm sitting in now. And talk to us some about the variation in density of the different kinds of materials you can grow.
Yeah, that's a great question. So today, our material is highly tunable in terms of its performance. As I mentioned, we can range from anything that's as cushioning as a plastic foam, such as expanded polystyrene or expanded polypropylene, to things that are as stiff as traditional wood products. And we do this by pulling one of two levers. We can either change the fungus that we're using, which is serving as the natural glue or adhesive, or the raw material. So we can go from something that's really light and airy, which is what we use in, say, our protective packaging blends and provides a lot of cushioning and resilience, to something that's a very fine particle, very similar to what you'd see if you took a cutout of or a cross-section of medium density fiberboard or particle board. By tuning these two characteristics, we can produce products that range from anything from protective packaging to insulation boards, surfboard blanks, and of course now even actual integral and structural furniture components.
Great. And talk to us some about what it's, manufacturers, and we do have some manufacturers in our boardroom here at our headquarters at World Wildlife Fund, where we're airing this conversation. Manufacturers have to watch their costs. Not all their costs are in the cost of a material, but what do you find your material is, where you are providing an engineered solution, how is that, is it cost effective relative to what is what I'm trying to say? Because there's so many, there's molded plastic and there's carved wood or various solutions you could provide alternatives for.
Fantastic. Yes, and actually I have a few very specific examples that I'd love to share with you today. So
okay.
First and foremost, when it comes down to cost, especially of manufacturing engineered wood products, almost 40% of the total cost of goods sold with things such as medium density fiberboard or plywood are the urea formaldehyde resins. And that's because they're derived from fossil fuel resources and they constitute up to 10% of the total product's weight. At Ecovative, we start with a very small amount of resin in the front end of our process, and over the course of just 3 to 5 days, that resin will grow, digesting and growing and producing more of the resin on the farm waste. So it's a self-replicating and self-perpetuating resin process, which allows us to keep our costs really low. So today, all the products that we sell in protective packaging or in the engineered wood space are cost competitive or parity with traditional engineered wood materials. I'd like to share an example of how this is working today. So for example, this is a part here made out of medium density fiberboard. This is a block of material that was made in 2 different sections, so that means someone had to come and glue these 2 pieces together. And then it used a traditional subtractive manufacturing process, such as CNC milling. That means it requires a substantial amount of on-machine time, as well as labor, and inherently generated waste that is covered and coated in synthetic resins such as urea formaldehyde. Using our new process for our engineered wood materials, what we've been able to do is grow that blank in just a couple of days and then compress it to get the same performance and same characteristics out of the material without any waste, and rather requiring hours upon expensive machine time, we've been able to press this part in just a couple of minutes. What's also really interesting and unique about this material is if you're looking for coatings, uh, oftentimes paints require a number of different coats on things such as medium density fiberboard or plywood. This material is inherently powder coatable and can use just a single coat to get a nice homogeneous surface finish. Same part, raw material, powder coating.
Wow.
So there's money to be saved on the raw material side as well as the processing side.
Yeah, yeah, that's very cool. And I love that you can powder coat it. That is really, really remarkable because I think of powder coating as being something for something very, very solid, like a piece of metal. But you're saying that the mycelium is as non-porous as the piece of metal for this powder coating process. Is that right?
Yeah, normally powder coating is dependent upon conductivity because that's how you get the powder coat to actually stick onto the material.
Right.
With medium density fiberboard and other engineered woods, either they make the material wet and then have to dry it later on, or add a metal salt in order to make it conductive, which of course adds additional cost. With our material, it's inherently somewhat electrically conductive, so that means that it can be powder coated without any additional inorganic additives, such as mineral salts.
Great. That is great. Let's see. Now, here's the thing I thought to wonder about growing mycelium. Growing plants absorbs carbon. Does growing mycelium absorb carbon?
It certainly does. So the way that our process works is that if you look at nature, within nature and within the ecosystem, fungi, or mushrooms, are the recyclers. They don't photosynthesize. They're not like plants. But what they do is they take the leaf litter and coarse woody debris that's produced annually and grow on and digest all of the things such as lignin and cellulose within the material and transform those materials into more mycelium. And that's how we grow and propagate our tissue culture and our resin. Because of that, it does require water. But just like a plant that has to grow, if it doesn't get water, it'll start to wilt. Same thing will happen to our fungus. We do have to add some water. At the end of the growth process, we inactivate it, meaning that you don't have to worry about it growing any mushrooms or producing any spores. The process has no spores or allergens associated whatsoever. And then at the end of that product's life cycle, it is actually sequestering the carbon that was in the plant. So all of the carbon that was once in the plant is now in the fungus. And that product is also 100% home compostable. And we have Biodegradable Product Institute certification, as well as Cradle to Cradle Gold certification, that says that you can take our protective packaging material, toss it right in your backyard, and in just 30 days, it'll turn into great compost for your garden.
Great. I love that about it. I love that. So there is a question about the limitations for using this instead of engineered wood. And I'm thinking, okay, if you throw it in the backyard and it decomposes in 30 days, this certainly is not something you're going to use in any application that's going to get wet regularly, just like you wouldn't use particle board in something that's going to get wet regularly. I think. Is that right? And what other limitations might there be for using it in lieu of engineered?
So the compostability associated with this product is not water. So the materials are not water soluble. And the reason for that is that the biochemical backbone of fungi is chitin, which is the same biopolymer you're going to find in lobster and crab shells. These materials actually have a lower moisture absorption and water swell rate than MDF and particle board today. Now, with that said, if you were to take this material, break it up into smaller pieces and put it into the dirt, it certainly will start to break down, just like any piece of wood or tree that you might find on the forest floor. Our limitations today are basically, number one, scale. We just launched this product about 6 months ago, and we're really focused on small molded shapes and applications, such as the chair back I showed you, or the desktop organizer, or this is a cool one. This is actually a hand plane for the surf industry, so you get to drive weight this one. But that's what our principal focus is today, is small molded shapes, areas where we can add a lot of value in terms of saving labor and machine time to make these custom molded products. And it's truly a design enabler. We're currently working to scale this process up And we're looking to do so by the end of this year so we can start to deliver large board stock materials for things such as case goods, anything from bookshelves to desktops.
Yeah, that's great. And so so small molded products. So if you had lots of furniture companies asking for a rectangle of the same size, that would be something you could scale up pretty quickly, would it be?
Oh, totally. We have the press capacity to do that today. And where our
Uh-huh.
value really sits is if you take a look at this chair back, for example,
Yeah.
it has curves in all these
Yeah.
different directions. Oftentimes, chair components, be it from the armrests to the headrests to the seat beds to the backs, they require some curvature in order to conform to the body for ergonomics. And that's something that we can mold in place and in process to reduce the amount of assembly time.
That's great. That's very exciting. Good. Well, I am glad this room full of furniture professionals is hearing about it. I've got a question coming in here. Um, let's see. Does it lend itself to handcrafted items, or is the fabrication limited to molded products? So do you have to mold that surfboard shape, or like fiberglass surfboards, which are molded somewhat and then sanded and carved down, can this material be treated that way?
It certainly can, and it is completely open and applicable to traditional machining methods, either in a home shop or in an industrial setting. And I'll bring this part back up just to give an example. So this space here is completely molded. This space was cut with a traditional table saw, and this space was sanded on a belt sander. You can also drill it, route it, and all of those kinds of things that you would see in a normal manufacturing setting. But yes, it does behave very similar to traditional MDF. And the nice thing about it is that you get the same feature resolution as you would out of an MDF or particle board.
Huh. Very interesting. And it's lighter than MDF, isn't it? Lighter weight?
That's correct. So that goes back to the being able to tune some of the mechanical performance. So one of the things we can do is when we're molding the shape, we can actually reduce the amount of weight by reducing the amount of material or farm waste we put into it on the front end. So for example, our materials today range from anywhere like a traditional MDF board to 40 pounds per cubic foot density to as low as our 6 pound per cubic foot density or 3 pound per cubic foot density that you'd see in either blocking or bracing or cushioning blended protective packaging.
Mm-hmm, mm-hmm, mm-hmm. Interesting. Let's see, there is looks like there is another question coming in there. So one of the other member companies in Sustainable Furnishings Council uses forest floor litter, Nature's Cast, uses litter and binds it together. Do you do anything with forest floor litter with little bits of twigs and things? I think it would be a harder sort of substrate material than your corn cobs and farm waste.
So we can use wood waste and forest waste. The principal issue and the principal reason why we don't today is collection. So today there are large-scale farms. They're collecting the corn stalks already. We can harvest those and process them to our specifications.
Yeah.
What's really unique about the fungal species that we use is that they can break down and they have the enzymatic toolkit to digest anything that contains lignin, cellulose, or chitin, which are the three most abundant biopolymers on our planet. That means we can use anything from twigs and leaves to lobster shells, which we have used lobster shells in the past, and we stopped using them because they smell bad. So, there's lots of different evaluation criteria for how we pick our raw materials.
Yeah, yeah. Yeah, that is interesting. And one of the textiles industry is very chemically intensive, and our next conversation actually is going to be about textiles. But one of the things that the textiles industry has to watch out for is how things smell, especially wool. So they have to scrub and scrub and scrub. So I bet you all would decide, because of your with your orientation, would decide not to use lobster shells because of the smell, rather than try to figure out a way to scrub it up. Is that right? Is that your inclination to go that way?
That's correct, but all of our raw materials, when we get them off the field, they do come in dirty. So we do clean them on the front end of the process because they come in with things like bacteria and mold. Nobody likes those things, and our fungus doesn't like those things.
Mm-hmm.
We make sure that the raw materials are completely clean and have no, what we call, bioburden on them before we end up shipping them out. So clean all of our materials on the front end, and at the back end, we're left with a clean, beautiful, and completely white piece of material. Like this
Yeah, that's great. And do you clean how do you clean what did you call it, bioburden?
Yeah, so we use a proprietary process that we've developed in-house. It is we both have continuous and batch processes, which makes sure that by the time that the raw materials come into our facility, that they're completely clean, and that we don't worry about any mold or what we consider competition for our fungus.
Yeah, that's great. Let's see, it sounds like maybe there is a question in the boardroom. Is there a question in the boardroom there?
I do.
Yeah.
In this material, what kind of finishes can you make from it? You know, if you wanted to try to replicate a wood finish, is that possible?
So that's a fantastic question, and we have done some preliminary exploration in embossing things like textures and features into the material, which is possible. One of the things we can do is similar to how we use the mycelium as an adhesive to grow and bind the farm waste together. We can actually grow to things such as textiles or laminates or veneers. And I've got an example of actually an automotive part right here where the material, needs to feature resolution on this is very, very tight, high precision, is actually grown into a hemp mat. That's for an acoustics property, actually. So that's one way that we can apply some finishes. And then, as I mentioned, it's completely compatible with different types of painting methods. And our idealized painting method is powder coating, just because of the low level of the waste that's associated with it.
Mm-hmm. That's great. So you're saying, Gavin, that if you wanted to have a surface, like maybe on the surface on the table in the boardroom, it's a slick surface. Could you grow onto a slick surface of some kind?
Yeah, to date, so all we need is some either abrasion or porosity to the surface. Wood veneers, for example, or textiles are great applications for this because they're already naturally porous and have some penetration for the mycelium to stick into. Because you can think of the mycelium as a bunch of little hairs, and those hairs have to find holes in order to make its way in and then bind to it. So anything that has some degree of porosity. And then we've even been able to grow and bind into things like metal. And we've done that just by abrading or roughing the surface, putting it right in direct contact with the mycelium or the mushroom roots while it's growing, and it binds right together.
That's very cool. Very interesting. Let's see. Any other questions in the room there?
Yes. Yes.
Somebody said a joke. You're going to have to, we couldn't hear it.
Well, I think we all thought that was a terrific presentation.
Yes.
And it was really, really interesting, and you presented it really well. But we are a little curious about your hat and flower. What significance does that have? Anything?
So we are a biomaterials company, and we're exploring lots of different opportunities for this material. Protective packaging, surfboard cores, as well as engineered wood. But we also have a team here at Ecovative that's looking at florals. And one of the unintended consequences of working with floral foams is that I've got a team full of scientists and technicians that are working with flowers every day. And I was told before I gave my presentation that I should probably put a flower in my hat.
That's great. Good. So you could grow a flower arrangement. Could you? Could you grow a base and something coming from it, or no?
So we can grow bases and composite cores that can hold things like flowers or be as stiff enough to hold nails and screws. We don't grow anything from those materials like mushrooms. We stay away from mushrooms. And the reason why we stay away from mushrooms is because when mushrooms are generated, they produce spores. And spores are human allergens. And we like to make sure that there are no allergens associated with our products.
Yeah, that is very important to avoid allergens. You know, when you won the Cradle to Cradle Products Innovation Institute's Innovation Prize not too long ago, one of the other winners was another company that is involved with us called Ecor that is turning no-value materials, you know, waste, like you're using farm waste. They are using things like cardboard that we throw away. And I wonder if you expect that next year and the next year and the next year there are going to be more and more companies competing for that prize that you won. And I wonder if you might speak to some of the other exciting companies like yours and materials unlike yours that are out there.
Yeah, certainly. So obviously there is a huge and growing need for natural alternatives to the synthetic materials that have become ubiquitous in our everyday lives. And that goes from plastic foams to traditional plastics to resin technology. And there's a single solution that's going to replace all of these plastics applications to date, because plastics have been around for a century and they're really exceptional in how they perform. So it really is going to be a collection of a number of different companies and different technologies that take us beyond our addiction to synthetics and plastics. You know, one that I'm excited about, and another one that was actually present at the Cradle to Cradle Institute Challenge is Biomason, which is a technology fairly similar to ours, except they use bacteria to transform things such as urea into a cement alternative. And of course, if you're familiar with cement, you're very well aware of all the carbon dioxide emissions and environmental burden associated with that product. And we're starting to see suites of materials ranging from plastics that use CO2 as their precursor materials, so they're sequestering CO2, through lots of other types of engineered wood replacements that are using clever resins and raw materials such as farm waste and other crop residues.
Mm-hmm. Mm-hmm. That's encouraging. That's encouraging. And the plastics are so laden with toxic chemicals, you know, and so it's exciting to me that ye who are developing materials these days are aware of those toxins, that the chemists who were coming up with these plastics just weren't thinking about the toxic about the toxins, I think, don't you? And that our being aware of problems of toxicity means you are thinking differently, as are the others.
Yeah, of course. You know, with introducing any new technology, there's always some unintended consequences. And we've had decades now to learn of the unintended consequences from synthetics. The precursors to these materials are naturally derived. They've just been derived over millions of years under a substantial amount of pressure. And now we're starting to deplete and consume them to a point where it's starting to have a negative impact on our planet. So what's really important for us, and one of our paradigms here, is that we focus on Earth-compatible materials, materials that derive all their precursors from nature and that can be put back into nature without having any detrimental impact, and ideally provide some sort of nutrition for the precursors and feedstocks we're going to use in the future.
That's a wonderful circle. Wonderful circle. Yeah. Yeah. Good. Are there any other questions in the boardroom there?
Where is Green Island, New York?
That's a great question. So Green Island, New York is located just 10 minutes north of Albany, New York. So it's about 2.5 hours north of New York City and 2.5 hours west of Boston. And it's located right on the Hudson River. So what's cool about our location here, and one of the reasons why we picked it, is because we're provided by 100% hydroelectric power, since we are right on the river.
Neat. That's great. That's great. And you're sort of at the same latitude but across the state from where the chemical industry around Buffalo has been so intensive, right? Aren't you on about the same latitude as Buffalo?
We are about the same latitude as Buffalo. We call that like the 90 corridor, because that's where Interstate 90 runs, is basically from Boston. So we are right in the same area. You know, our focus is to be really close to farms, and that's why today we're located in upstate New York and not in an urban setting, because we are surrounded by an abundance of things like corn crops or soy crops or specialty crops. We have a plant with the Sealed Air Corporation, which is manufacturing and licensing our protective packaging product under the trademark Restore Mushroom Packaging. They're the great people who provide, like,
trademark again?
Restore Mushroom Packaging.
Restore Mushroom Packaging. Good.
Yep. So they're located, and they have built out a plant using our technology in Cedar Rapids, Iowa. As you can imagine, there's an abundance of corn in the Iowa area.
Yeah. Yeah. That's great. That's great. Okay. Let's see if this means there's a question coming in here. And I think we don't have any other questions right there. So do we have any other questions in the room?
People work, how many people work there? How many people work at Ecovative?
Right now we're just over 70, and we have a pretty interesting mix from former farmers who now work in our materials supply division to engineers who build and construct and design complex automation technology to really make this process a high throughput process, to fantastic biologists and chemists that are working collaboratively in order to introduce new products ranging from the floral foam that I mentioned to even construction materials like rigid board insulation.
Great. Great. Gavin, thank you for inventing this material and others. You've invented other things too. I didn't mention that you have several utility patents to your name, but you are. I have the impression you're quite the inventor, and I do thank you for all you're providing to our industry and to the world. And I think that if there are no other questions, we will let you conclude with whatever message you would like to leave us with.
Great. Well, Susan, I really appreciate the opportunity to present to you and, of course, the Sustainable Furnishing Council. You know, we here at Ecovative look to provide no-compromise materials. And that means no compromise in performance, cost, and, of course, impact on the planet. And we're always interested in exploring new opportunities in furniture and in protective packaging. And we hope to speak to whoever's interested in the future. So thanks again for the opportunity, and appreciate what you're doing here with the council, spreading the good word.
Thank you. Thank you so much for being part of what we're doing. And if anybody has any residual questions, you can contact us through our website. And we're going to start our next conversation in this series, which will be about textiles, at the top of the hour. So tune in for a conversation about why and how to green your textile choices at the top of the hour. Thank you for having been with us for this conversation.